So I've been an astronomy buff since I could read. I've been an astronomy buff for ever and ever, for the vast majority of my life, whether if it's the solar system or other galaxies or learning about black holes, supermassive black holes, the origin of the universe, the age of the universe, dark matter, dark energy, galaxies, galaxy clusters, filaments. The list goes on and on. I mean, whatever it is, when it has to do with the universe, the cosmos, I'm interested in it. And I came across this one actually surprisingly not too long ago. There's an object that flew past the Earth, extremely close to the Earth, relatively speaking, and it was around the year 2017. And I actually had to look up how to pronounce this word because I didn't know how to pronounce it at first. But it's called Oumuamua, and it's a very fascinating object. And people believe that it could potentially be an alien ship, although I highly doubt that it is. But with that said, the size of it, the shape of it, and the speed at which it was traveling through our solar system, it's very strange, and it's just very out of nowhere. It came from interstellar space. It didn't come from the Oort cloud, which is beyond Pluto. The Oort cloud is collections of trillions of rocks and debris, dust, things like that, ice and whatnot. And that's where a lot of our comets, actually probably most, if not all of our comets, come from the Oort cloud. But this object didn't come from there. It was traveling way too fast for it to have had any origin in our solar system. It just literally flew right through our solar system, and it's on its way out right now. And it was back in around 2017 when they discovered it, and they're still trying to study it, still trying to analyze it. They didn't discover it until it was pretty much flying past the Earth. And I guess scientists they wish that they would have detected it a couple of months earlier, because they would have been able to focus all of our instruments directly at it. So they would have been able to get more accurate scientific data on it, as opposed to turning everything toward it as it was moving away from us. So, but anyway, I came across this video on YouTube, and it's a great one. It's very fascinating. So buckle up. This is going to be awesome.
A mysterious object.
And by the way, this is from Astrum. It's an awesome YouTube channel. Definitely go check it out. I've been subscribed to him for a while.
It is the first interstellar object we've ever detected. But by the time we realized it was actually in the neighborhood, it was already on its way out. With limited data, we aren't actually sure what it actually is.
I know, we don't know, man. We don't know.
Simply being interstellar is not
the Sulaco from Aliens.
Apart.
Kind of looks like it a little bit.
To what we saw Oumuamua do. An event so strange, so in defiance of the laws of physics, that some scientists have turned to the explanation of alien technology as the only means to explain it.
I don't know, bro.
What is Oumuamua? What did it do?
What indeed?
And are there more objects?
Sorry, I gotta throw my voice in here because, you know,
I'm Alex McColgan,
it's YouTube,
and you're watching Astrum. Join me today in a deep dive supercut into our first interstellar visitor, the theories that surround it. And
oh hell, man! I'm instantly giving this a like. I thought I already liked this video.
The mystery once and for all.
And it tumbles. You see how it was turning like that? That's how it travels through space. It actually tumbles.
In the science community as to how many extrasolar objects pass through our solar system. Some think we regularly see visitors, with up to 10,000 per day passing within the orbit of Neptune. That seems like a lot. So let's figure out.
Sounds like a far distance, but it really isn't. Not in the grand scheme of things.
The first thing to understand is that
the fastest spacecraft that we've ever built, the speed at which it travels through space, like it's heading out, I think it was the New Horizons spacecraft, if I'm not mistaken. I mean, don't quote me on it, but I think it is. It's the one that took pictures of Pluto when it flew by in, what was that, 2015. And fastest vehicle that's ever traveled, made by human hands, and even that vehicle will still take over 50,000 years just to get to the nearest star, the Alpha Centauri system. So space it's unimaginably huge. Trillions of miles between the sun and the nearest star. And we've got over 200 billion, with a B, billion stars just in our galaxy alone. Just in the galaxy, 200 billion. Which is kind of wild, just to think that, you know, for example, Elon Musk, he has twice that amount in dollars. It's absolutely wild. But anyway, that's beside the point. But we're nestled inside the galaxy. We're not on the razor's edge of the galaxy. We're not on the outskirts or anything like that. We're nestled in a pretty good way, like not quite halfway between the edge and the center of the galaxy, but we're not. We're probably about, I don't know, probably about 40% of the way in toward the center of the galaxy. So we got a lot of stars around us. I mean, countless and countless numbers of stars, but the distance is just so unimaginably huge. And just the thought that there could be up to 10,000 objects flying through the solar system within the orbit of Neptune that's kind of scary. I mean, it is a long distance between the Earth and Neptune, but again, in the great scale, it really isn't. I mean, we are extremely close together when you really look at the bigger picture.
The solar system extends way beyond the orbit of Neptune. Beyond Neptune is the Kuiper Belt. Beyond that is the Oort cloud.
I forgot about the
Oort
Kuiper
cloud
Belt.
Contains potentially trillions of comets that are gravitationally bound to our sun. Some of the comets that we see that pass by the sun likely came from and will return to this Oort cloud with their extremely elliptical orbits.
Yeah, look at that.
Taking
those are all comets
to hundreds of thousands of years to do so.
Well, all of their
Some of the
trajectories
comets we see from the Oort cloud would never come to the inner solar system were it not for massive third bodies which perturb these comets' orbits with their gravity so that they fall towards the inner solar system. These third bodies are often other stars. You see, the solar system is not stationary like we sometimes may perceive, but we are constantly
it's on the move,
moving,
buddy.
orbiting the galaxy. As we move in our orbit, we cross paths with the gravitational influence of other orbiting stars. Even distances of
just a little tidbit. It takes the solar system, the sun, roughly about 100 million years to make one revolution all the way around the Milky Way. Because the Milky Way it's rotating. We're rotating around the center of the Milky Way, which is Sagittarius A. That's the name of the supermassive black hole at the center of the Milky Way.
A couple of light years can be enough to perturb a comet so it comes crashing down towards the sun.
Yep, falls into the sun.
It can also be enough for the comet to be pulled away from the solar system altogether, joining the ranks of the hundreds of trillions of interstellar interlopers found in the galaxy. As an Oort cloud-like body is likely not unique to our solar system, it must mean that comets are constantly being lost and others are being captured by stars throughout the galaxy every day.
Oh, for sure.
Although generally speaking, what we've seen of Oort cloud objects so far imply that the majority of comets in our Oort cloud did originate with our sun, because they are mainly
a lot of the
similar in composition.
The tail of a comet, a lot of that.
As the solar system
that tail is made up of water.
We also cross
water
the path
and dust.
Of interstellar interlopers that have been pulled away from their
when it gets close to the sun heats up the comet. That's what creates that tail.
They often approach from Vega, because that's the direction our solar system is heading through the galaxy.
All right, heading
While
toward Vega.
The sun does capture some of these objects, most are traveling so fast relative to us that they pass right through the solar system, only having their direction of travel changed as they pass by the gravity of the sun. Oumuamua is one such object.
Oumuamua, there it is.
Oumuamua was first seen in our solar system on the 19th of October 2017 and was spotted by the Haleakala Observatory in
October
Hawaii.
19th.
It was originally thought to be a comet when it was first discovered.
That is a weird shape, man.
C 2017
that does not look like your
U1.
average
But upon
rock.
further investigation, it was reclassified as asteroid
like a cigar.
A27U1 when no coma around the comet could be seen, becoming the first object to ever get a reclassification like that. Once the orbit of Oumuamua had been established, it also became clear that it was traveling too fast for it to be in orbit around the sun. We say that the object like this one has a hyperbolic trajectory. Because its velocity will see it leave the solar system altogether, it likely didn't come from the solar system to begin with.
Nah,
the
going too
object
fast.
was thus given its Hawaiian name Oumuamua, meaning scout or first distant
discovered
messenger.
by the Keck telescope, I think?
The International Astronomical Union had the unusual task of having to create a new classification of object.
You see the sun actually
Oumuamua. They decided upon I for interstellar, so Oumuamua's designation is now 1I 2017 U1.
One eye.
As
the
the
I
first
is
of
for
its kind that
interstellar.
we know about, scientists were excited to study Oumuamua
Because
to learn what characteristics
pretty sure it came from outside the solar
that
system.
made it similar or dissimilar to objects found in our own solar system. Scientists quickly noticed that there was something strange about this object. It was small, perhaps between 100 and 1,000 meters long, and was believed to have an unusual shape. Perhaps a cigar or a flat dish.
A cigar.
It is believed to have this shape because its brightness pulsated over its 7-hour rotation period. This was because we received more light from its reflection when it appeared longer from our perspective. However, this could apply just as easily to a saucer-shaped object.
So if it is an alien ship, then it must have lost its power or energy source or something, which would have set it off on this spin. Or maybe it could have interacted with something while it was traveling, and it may have just knocked it into this spin. Because, you know, when you're out in space, if something just nudges you, I mean, you don't stop moving and spinning like it is. I mean, it's probably been spinning like that for millions and millions of years if it's a natural rock, which I mean, like 99.9% sure it is not an alien ship. But, you know, I'm entertaining it, though. I mean, it's possible. I mean, anything's really possible out there.
It also appeared to be tumbling rather than rotating along a set axis. Oumuamua is unusual for more than just its shape. As it is like an asteroid, it must have originated from the inner part of its home system. So how did it get ejected and make its way to us? Is it from a collision of huge proportions? Alternatively, maybe it really is a comet. But as it traveled through interstellar space over millions or billions of years before it got to us, it had been coated in dust, meaning that the volatile materials typically found on comets weren't exposed to the sun.
Oh, right.
But while these elements were intriguing, the thing that really set Oumuamua apart from other objects was its motion.
Its motion, yep, its speed, right?
Oumuamua passed its closest point to the sun on the 9th of September 2017 at a brain-melting 87 kilometers per second. But when it headed back into space, it didn't slow down like normal. Scientists watching it detected an inexplicable burst of acceleration, counteracting the pull of the sun's gravity. Rob Warwick, who is credited with the discovery, said, "Its motion could not be explained using either a normal solar system asteroid or comet orbit." The rate of acceleration...
Just to let you know, 87 kilometers per second, when you convert that to miles an hour, it's traveling at 194,613 miles an hour. Freaking
was
fast.
Minor. Only about 17 meters per second when it was
to have a stationary orbit around the Earth. You have to be traveling roughly around 17,000 miles an hour to have a stationary orbit going just around the Earth, like the International Space Station. I think it's roughly around 17,000 miles an hour. That's how fast it has to travel to remain stationary, going around and around. If it moves any faster, it'll start moving farther away, and eventually lose its orbit around the Earth. Too slow, obviously the opposite happens. It falls into the Earth. So 200,000 miles an hour, that's pretty damn fast.
Nearest the sun.
That's really fast.
And yet this was enough to cause a stir in academia. Oumuamua was not doing what physics said it should do.
Oh yeah?
In the next few months, scientists were able to observe it. Oumuamua was deviating from its path. In physics, objects can only accelerate when they are pushed. So scientists began to try and explain what was pushing Oumuamua. A few initial hypotheses were quickly ruled out. This did not seem to be simple solar winds giving a small nudge. While it is a recorded phenomenon for the small trace particles fired off from the sun to push at objects in space, this small force was not enough to explain Oumuamua's acceleration, assuming it was an ordinary asteroid. Scientists reached for another example in our solar system of accelerating objects: comets.
Okay.
As comets travel close to the
they're
sun,
assisted by the sun,
ice within them warms and sublimates, turning into gas and spouting off from the comet's main body. This outpouring of gas and dust forms the comet's signature tail, but it also gives the comet a little push, acting
gas
like a
is
little
mostly
thruster
water
on
vapor.
the side nearest the sun that accelerates the comet away from the source of all that heat. But scientists could not detect all that dust and gas coming from Oumuamua.
Right, it had
to be
no
sure,
tail.
the Spitzer infrared space telescope spent 30 hours trying to get any kind of reading on Oumuamua, but couldn't, meaning this object emitted nothing in the infrared. Typical comets have comas and tails that Spitzer can spot, like in this image.
So obviously not a comet.
Adding further intrigue to the debate, readings from Spitzer Space Telescope also indicated it was at least 10 times shinier than a typical comet, which would fit well if it were made out of something metallic. Then,
could have been made out of metal.
Oumuamua? Let's take a look at an argument
Maybe
between
alien
two
origin?
theorists with two theories. The first theory was the most headline-catching. Harvard professor
I'm sure.
Avi Loeb promoted in numerous papers that Oumuamua could represent alien technology. He argued in 2018 that solar winds could provide the acceleration seen with Oumuamua,
Maybe.
but only if Oumuamua was actually much thinner than scientists originally assumed.
Or much more lightweight.
Between 0.3 and 0.9 millimeters thin.
What?
As a 1,000 meter long, 1 millimeter thin object was unlikely to appear in nature, Loeb argued that this had to mean it was artificial, a light sail created to catch solar winds and use them to accelerate through space from one star to another. This theory met the resistance from other members of the academic community. Darryl Seligman, our second theorist and a postdoctoral researcher at Cornell University, countered by co-authoring a paper in 2020 that said that perhaps the reason no outgassing was detected from Oumuamua was because Oumuamua was emitting an invisible gas, such as hydrogen. This would not have been detected.
Look, that's even fascinating to think of on its own, that it could have possibly been sent here as like a probe of some sort from another planet. And he'll get into it here in a little bit as to where they believe that it came from. And I don't know if he goes as far as to help us figure out if we know of any planets that are around that star, especially potentially habitable planets. But it begs the question, at some point in history, it could have been 10, 20, 50, 100 million years ago, there could have been intelligent alien life on a planet, 5, 6, 700 light years away, wherever Oumuamua may have come from, and they may have sent it in our direction because perhaps they had their own versions of telescopes and they were looking down into our solar system from afar, and they were detecting the signatures for life when they were looking at our solar system, and they were able to catch like the transit of the Earth going across like in front of the sun. And I mean, that's how we detect the potentially habitable planets at this point. We can, what is it, like a spectroscopy or I don't know. I can't remember exactly, but they're able to figure out what the atmosphere of planets are made out of when the planet transitions in front of that planet star and us when we're looking at it. And it's able to pick up on the different elements that this planet is potentially made out of. And they can get like a rough estimate as to like what the planet's composition might be. Well, maybe some alien civilization, they could have been way more advanced than we are today. I mean, the universe is 13.72 billion years old. And I mean, humans, we've only had our technology for a few hundred years. I mean, Galileo was only like, 400 or 500 years ago when he built the first telescope. So, I mean, who knows? And they could have actually sent something toward our solar system with them well knowing that it's going to take thousands and thousands of years for this object that they're sending toward us to get here. And maybe it will maybe it was designed to radio back something or whatever. And maybe along its journey, something knocked it off of its trajectory slightly, and maybe that's what caused it to start spinning like it is right now. I mean, there's a million different questions and different directions you can really take this overall theory as to what Oumuamua could be. But I mean, I guess it's possible. I mean, 200,000 miles per hour. I mean, you could do the math, and he will eventually say about like roughly which star that Oumuamua may have originated from, at least the scientist's best guess, and he'll tell us how many light years away it is. And you can do the math to determine how many years it must have traveled to get here if it were traveling 200,000 miles an hour the whole time. But maybe it was sent at a much faster speed, and maybe it did have technology on it to slow down before it got into our solar system, so it wasn't traveling too fast to the point where it wouldn't be able to do whatever, snap photos or whatever the hell it was sent here to do, take readings and whatnot. So it's possible it could have slowed down and then passed through the solar system. And then once it passed through the solar system, then, they're done with it. That's the only thing they sent it out to do. But yeah, it's fascinating. It's, your imagination can kind of run wild with that.
Using the
really
telescopes
interesting.
That were trained on Oumuamua.
Again, I highly doubt that's really what it is, but
was entirely or
it's fun to have your imagination run wild sometimes.
A hydrogen iceberg that was sublimating thanks to the warmth of the sun, and it was that sublimation that was causing the push. Loeb disagreed. A few months later, he co-wrote a paper asking where exactly this hydrogen iceberg could have come from. He showed
let's get into it.
That the starlight in the interstellar vacuum was warm enough that any hydrogen iceberg that formed in even the nearest densest molecular clouds would have melted before they got here. Loeb was still convinced that an alien explanation was the most probable.
Really? You really think so?
His reputation was strong enough to send Seligman back to the drawing board, who dropped the hydrogen iceberg idea. However, Seligman continued to play around with the idea that
NASA's thinking about building something to chase after this thing. There's some people that are so convinced that this was of alien origin. Like they're actually busting out the drawing board for that.
He met with
I don't think they're going to be able to because it's moving really fast.
Jennifer Bergner, who pointed to experiments in labs where water ice in extremely cold conditions, hid with radiation, could trap pockets of hydrogen, only to release it later when warmed up as the ice structure rearranged itself. As it happened, water ice is much more plentiful in space, and so is radiation.
Oh yeah, water is extremely plentiful out in space.
The pre-baking that would be needed. Between the two of them, Seligman and Bergner wrote a paper arguing.
There's more water. Excuse me. Sorry. There's more water over on Europa, which is a moon that orbits Jupiter. There's more water on that moon than there is on the entire Earth. And I think there's a hypothesis that I think it might be Enceladus. It also has water geysers that are constantly just firing off, and that moon orbits Saturn. But yeah, Enceladus. But even that might even have almost, if not more water than all the water that exists on Earth. So, and Enceladus, it's only about 300 miles wide. It's a pretty small object. So water is everywhere out there, and not just in our local area in the solar system, but water, we believe, is just all over the place. It's a mixture of hydrogen and oxygen, 2 parts hydrogen, 1 part oxygen. Those are among the 2 most abundant elements in the entire universe, hydrogen being number 1, and oxygen, what is it, like number 4, number 5, something like that, in abundance. So, it's not a crazy thought to think that water exists literally everywhere. It's all over the place.
Oumuamua needed a new category entirely. It wasn't a regular comet or an asteroid, but rather a dark comet, one with a coma that was invisible but present. Their explanation accounted for Oumuamua's acceleration, and
that's
also
crazy, man. Isn't that awesome how the sun made it turn like that?
Dark comets would not need to release dust, as they were simply reconfiguring their structures and releasing the pockets of invisible gas, rather than blasting gas out from its surface like a small gassy volcano. While this was not enough to convince Loeb, who co-authored 2 more papers in the next month.
That's an artist rendition, by the way. That's not an actual picture of Oumuamua.
While also continuing to push his alien spaceship model, Seligman was already considering the next step in his own logic.
They weren't able to get any close-ups of it.
If Oumuamua represented a dark comet, could there be other dark comets out there?
Oh, absolutely.
Bergner and others began pouring through the data of objects already existing in our solar system. They might not be interstellar, but was anything else in the solar system accelerating when it shouldn't be?
Yeah, that's a weird question.
They found 6 that matched their criteria.
Really?
6 objects that showed non-gravitational, non-solar wind-based acceleration that couldn't be explained away by any known mechanism.
Interesting.
These objects were small, some just as tiny as 3 meters across. They looked like asteroids and didn't have remarkable features. They were near-Earth objects.
Isn't that wild how they can freaking point telescopes out into space? millions of miles away potentially, and they can find objects that are floating out there that are only 3 meters across. I mean, isn't that like less than like 12 feet, 12 feet across? And you pretty much just hurl a car way beyond the moon, just like out into the solar system somewhere. And our telescopes are powerful enough to actually pick up that object out there in space. It always blows my mind.
Orbiting close enough to
something
Earth
that small can still be seen from that far away.
Viable. And they were all exhibiting signs of acceleration. To be clear, such acceleration was very minor, small enough to have been overlooked previously. These objects aren't zipping around the solar system from planet to planet like spaceships. They are not interstellar objects. But, just like Oumuamua, science cannot currently account for their motion, especially given that they do not have any visible signs of outgassing. And intriguingly, one of them is already scheduled to be visited by 2031.
All right.
1998 KY26 is due to be visited by the Japanese Hayabusa 2 probe, an asteroid sample return mission that was launched in 2014 and finished its primary mission 6 years later, but since has been given a mission extension to visit other asteroids in the near-Earth Apollo group.
That's cool.
1998 KY26
that's cool.
is rotating quickly, once every 10 minutes, and Hayabusa 2 will aim to perform a flyby to learn more about this water-rich, tiny object
so it's
for
not
the
going to land
benefit
on
of
it.
future human missions to Mars. Once it's there, perhaps it will become clearer what the source of 1998 KY26's strange acceleration might be.
Wow.
It's still not obvious who among the various scientists out there is right about Oumuamua, but it's undeniably intriguing that more objects exhibiting strange acceleration have been detected, and highly likely that they will shed further insights into Oumuamua's possible nature and origins. If they are found to accelerate through invisible outgassing of hydrogen, Seligman will stand validated. But if a little hatch opens up and a small alien form peeks out to wave at us before accelerating off out of the solar system, then we might regret not listening more closely to Loeb.
I don't know about all that, but
I think the former is more likely than the latter, as there is no way 1998 KY26 is a light sail. We have excellent imaging of this one, but either way, it will be fascinating to study. Exploring these dark comets within our solar system grants us greater insight into Oumuamua's nature. But what then of other interstellar objects? Have there been many others since Oumuamua? We've had other visitors from outside the solar system, but this next one is a little more conventional.
Yeah, it's not like a weird long cigar shape. Could be an alien spacecraft kind of deal.
It's been given the designation 2I Borisov. Zooming in on Borisov reveals that this object had a big comet-like coma and tail, almost the size of 14 Earths across.
Damn.
We couldn't see it with the naked eye,
That's a big tail.
as the closest it got to the Sun was beyond the orbit of Mars in 2019. Borisov was roughly the same size as Oumuamua, about half a kilometer across. After its closest encounter with the Sun, it began falling apart.
Big.
This is reasonably normal for a comet of this size passing by at this distance. Also, its composition, while uncommon, isn't particularly unusual either. Because it passed through the solar system at a greater distance than Oumuamua, its trajectory wasn't hugely affected by the Sun's gravity.
Yeah.
So, overall, apart from its I classification, it's a somewhat unremarkable object. Now moving on to some other interesting interstellar objects that do not have the I classification.
Let's go.
C1980 E1 was originally a solar system object with an orbital period of 7.1 million years.
Holy shit.
The furthest its orbit used to take it was
it takes 7.1 million years to go around the Sun one time.
However, it passed a little too closely to Jupiter during its last approach in 1980. Jupiter's gravity accelerated it just enough for it to get a hyperbolic trajectory. And so, this object will eventually become an interstellar interloper itself when it leaves our solar system in a few million years.
So it gave it enough of a boost.
We have had the opposite happen.
So it might be heading out like
objects have had
maybe
their velocity
permanently
slowed down enough by the gravity of Jupiter that they became captured and locked into our solar system.
Yeah, that could happen too.
I mentioned Jupiter specifically because it has been
It's a
determined that
monster.
other planets aren't massive enough to do this, and it has to be a third body beyond the Sun and the comet that does the slowing down or speeding up.
Yeah.
Mach-Holtz 1 and Hyakutake C 1996 b2 are potentially such captured interstellar comets from another planetary system. The giveaway for objects like these are their highly elliptical orbits and their very unusual compositions compared to the majority of other comets. This makes them interesting and viable targets for future missions, as the solar system might have done all the hard work for us in capturing interstellar objects and putting them within arm's reach. There's one more giveaway that an object might have extrasolar origins, and that is if it is orbiting retrograde to pretty much everything else in the solar system. An example of an object like this is 514107 Kuiper Oka Avela. What makes this object especially interesting is that it is also an asteroid, unlike most other interstellar objects we would expect to see. It could also be that the volatile materials have already burned off if it was once a comet, meaning it would have been captured very early in the solar system's past. Its orbit is also unusual in that it is locked in a 1-1 orbital resonance with Jupiter. While these objects are interesting, they don't settle the question of Oumuamua's nature, and there's much we still don't know.
Its shape,
For example, where did it come from? We don't know, but we do know it came from very, very far away.
But they can sort of estimate.
Star system,
I think they give like a ballpark maybe where it could have come from.
It seems to have come from the direction of the star Vega in the Lyra constellation.
Yep, which happens to be the direction the solar system's heading.
Home stars Oumuamua could have come from, some as far as 81 light years away. But there haven't been any definitive answers on its origin story yet. And now it is over 6 billion kilometers away, moving at 26 kilometers per second towards Pegasus, about as far as Voyager 1 was when it snapped the famous pale blue dot image. Even if Oumuamua is not a piece of alien technology, it holds importance as the first confirmed interstellar object to enter our solar system. So it is no surprise that scientists want to take a closer look at it. We noticed it only 40 days after it passed its closest point to the Sun.
Yeah, doesn't that suck?
By then, it was already 33 million kilometers from Earth. We sent...
Yeah, see, they discovered it over a month after it already passed by the Earth. That's when they just caught it. I'm assuming it... I think it's the Keck telescope, I think, the one up in Hawaii. That's probably the one they found it with, given the name. But, yeah, I mean, that kind of sucks that they just didn't happen to detect it until it had already passed by. And the speed at which it's moving, what did they say? It was like 30 million something kilometers away from us by the time that we first saw it. And it was already just, by the time we saw it, it was obviously just getting smaller and smaller and smaller from our view, just because it was just heading out. And yeah, that's too bad, because if they would have focused all of our instruments toward it as it passed by at its closest approach, we probably would have been able to get a better sense of its composition. And I don't think it would have been close enough for us to get it, like an actual detailed photograph of it. But I mean, maybe not. I don't know.
Ground and space telescopes into overdrive, trying to answer the questions surrounding it before it escaped our grasp. But 2 months later, by mid-December, it was already too faint and fast-moving to be studied by even the largest ground-based telescopes.
Yep.
With limited data and more questions than answers, some researchers believe the only way to learn more about Oumuamua is to send a mission after it. However, catching up to Oumuamua is a significant challenge for 3 main reasons. The first obstacle is gaining enough speed to catch up.
It'll take a long time.
Is over 6 billion kilometers away and careening through space at 26 kilometers per second.
6 billion kilometers
away. No chemical rocket that exists today can reach that speed.
It flew by in 2017.
Making a rendezvous difficult. And once we've caught up to Oumuamua, the second challenge is decelerating enough to actually study it. If we don't slow down, we'll shoot right past it.
Oh yeah,
and
absolutely.
Won't be able to collect any scientifically useful information.
You got to send a lot of fuel to slow it down too.
It is difficult to find such a small object in such a large galaxy. Remember, Oumuamua is just 1,000 meters long at most, tumbling through the vastness of interstellar space.
Yeah, I think I don't know, man. I trust our NASA scientists. I think they'd get it down.
Plans to catch up.
I think they'd be able to
accelerating to the speed
send
necessary
it
to
in a straight
catch up with
direction.
Oumuamua is difficult, it can be achieved through the use of gravity.
The only problem would be for it to be able to accelerate to a speed. I mean, whatever we send after it, it's going to have to be going at least 195,000 miles an hour just to be able to slowly start to try to catch up to it. And even if it's going at that speed, it's going to take hundreds of years for it to catch up eventually. I mean, you'd have to send it after it going like maybe 250,000 miles an hour, maybe even like 300,000 miles an hour. But you're going to, if you send an object after it, like a space probe to catch up to it, and if it's going 300,000 miles an hour, I mean, yeah, it might catch up to it, in a couple decades or so. But once it starts to approach it, they got to figure out how to slow it down by 100,000 miles an hour, or else, like he said, it'll just fly right past it. It won't have a chance to slow down and actually, study it for any length of time, unless if it is flying past it real quick, you might get like either a few hours, probably at most, maybe a few hours worth of time to study it in detail as it zips right by it. But in order to get an object to go at that speed, you're going to have to use the planets to assist in speeding up that spacecraft that we'll send after Oumuamua. So basically, we would have to send it probably in toward maybe Venus, or even just maybe going around the sun to pick up speed, because that's how they usually send, like the New Horizons spacecraft, like I mentioned earlier. They had to send it around a couple of planets at least a couple of times to get it to pick up speed. Because as it slingshots around a planet, it picks up speed. Like when it goes around Jupiter, for instance, and then it heads in another direction, which it's heading toward like Mars or Venus or whatever, or even sometimes even the Earth. It'll come back to the Earth, and Earth will accelerate it a little more as it orbits around and back and forth, picking up speed each time that it's slingshotting around another planet, which obviously that takes years to do. I mean, it could take the better part of a decade, if not longer, to get it up to that speed, to the point where, all right, now it's traveling fast enough. Now we can send it out toward Oumuamua. So almost like, think of like a pinball machine, like just bouncing from planet to planet, gaining speed each time it slingshots around another planet. I mean, all these different directions and trajectories. And then finally it's going at the speed where they can send it out toward it. It has to be heading at a perfect straight line because Oumuamua is so small, at most 1,000 meters in length. So I could see the challenges, but I really think that NASA could be up to the task. I mean, they've done pretty wild, amazing things. It's unbelievable what they've been able to do so far. So, I mean, I don't think it's going to happen because it's going to cost a hell of a lot of money, and it's going to take a lot of time to do. And the odds of it catching up to it successfully are probably going to be relatively slim. But I mean, it could happen, but is it really worth it though? I mean, like, do they really think that there is really something there that is worth going after it? Because it's going to cost billions and billions of dollars to do this. And is it worth the taxpayers' money to spend it on such an endeavor? Because it could just turn out to be nothing but just a dead rock, in which case it was just kind of a waste, other than just for the sake of, yeah, we did that. We were able to actually catch something that was moving 200,000 miles an hour away from the solar system, and we were able to actually catch up with it. I mean, amazing bragging rights. I don't know if it's like, $20 billion worth.
The most famous examples of a solution come from Project Lyra, launched by the Initiative for Interstellar Studies. They've presented two different trajectories we could send a probe
man, they
on.
even typed up papers.
The first requires 3 distinct changes in velocity. First, we accelerate the probe out of Earth's orbit.
All right, maybe this will happen.
Jupiter.
I don't know.
Once at Jupiter, the probe slows down enough to fall towards the sun. Less energy is required to do that from here than from Earth, as Jupiter's orbital velocity is less than half of Earth's. And as our probe approaches the sun, it's traveling at its fastest. At this point, the rocket engines ignite to give it the biggest acceleration possible for the amount of fuel carried, a technique called a solar orbit maneuver. By harnessing a solar orbit maneuver in this way, researchers predict their probe will shoot out of the solar system at over 70 kilometers a second.
Woo!
While that is definitely fast enough to catch up with Oumuamua, there are still a couple of problems with this plan. Such a close approach to the sun requires a
No,
heat
wait a
shield
minute.
to protect the...
They said 70 kilometers a second. That's not fast enough to catch up to Oumuamua. They said Oumuamua is traveling at 87 kilometers a second. So that's not fast enough. So I mean, I don't know who's got the math wrong, but those two numbers, they're not quite jiving. Unless Oumuamua is traveling at 70 and they're trying to get the spacecraft up to 87. But if that's the case, he said those numbers backwards, because he definitively earlier said that Oumuamua is traveling 87 kilometers a second, and this thing can only max out at 70. So I don't know.
The good news is that
not sure what to say about that.
Such a shield exists, as the Parker Solar Probe used something similar. The bad news is that it weighs 72 kilograms, putting a limit on payload mass. Next, sending a probe from Earth to Jupiter to the Sun and back out to Jupiter to be sent out in the right direction is quite a long trajectory.
Yep, and they're doing that to pick up speed.
There's a shorter way to do it. And finally, this plan requires
like a pinball.
using maneuvers that have never been carried out in a real mission before, giving it a low technology readiness rating. Plus, if you've seen my video about falling into the sun, you know just how hard it is to do so.
Yeah.
There is, however, another
and dangerous
way to
on the
catch up to
spacecraft.
Oumuamua. The second trajectory proposed by Project Lyra is as follows. Launch from Earth, swing around Venus and Earth, conduct a deep space maneuver to reorient the probe, swing by Earth again, then use a gravity assist from Jupiter to catapult our craft towards Oumuamua. This plan doesn't require a heat shield,
That's so cool.
is a much shorter trajectory, and will result in a slower final speed of our probe as it heads into interstellar space. This would make it easier to decelerate on approach to Oumuamua and allow for better data capture. Project Lyra has identified at least 2 viable missions with launch dates between 2030 and 2033, and an arrival at Oumuamua at 2048.
I was going to say, the longer they take, the longer it's going to take to catch it. It's moving quick.
A mission to Oumuamua is inevitable. After all, researchers are crafting proposals for missions to planets of other solar systems. But even 100 years from now, Oumuamua will still be much closer than those destinations.
Oh, absolutely.
But could there be a better way to get the data we want? What if we could have anticipated Oumuamua months in advance?
Yeah, that would have been nice,
after it had already passed by. Astrobiologist Karen Meach of the University of Hawaii, who led the characterization of Oumuamua after its discovery, says we'll soon be able to do this for other interstellar interlopers that might cross our paths. NASA estimates that an interstellar interloper similar to Oumuamua passes through the inner solar system once per year. Since they're so small, they are hard to spot. Until now. The
now that we know what to look for.
telescope, set to become operational later this year in late 2025,
Rubin Observatory.
Spot these objects a whole 3 months before the telescope that detected Oumuamua.
All right, let's go.
It will get busy building the Legacy Survey of Space and Time, a database of 2 million images taken over a decade. This data will be ideal for identifying changes in the night sky, including the trajectory of comets and asteroids. A 2023 paper estimated that the
they can use the stars as the background.
Could find up to 70 Oumuamua-like objects per year. Another initiative to better understand interstellar objects is ESA's Comet Interceptor mission, set to launch in 2029. It will park a probe in space for up to 3 years while waiting for a comet or an interstellar object to fly by. It'll then spring to life at the right time and carry out a close-range flyby to build a 3D map of the object. It will be the first ever mission launched with an unknown target.
With an unknown target, that's cool.
We don't know how long we'd have to wait for another such object to cross our path. It would be a terrible waste of time, energy, and money if another Oumuamua-like object didn't fly past in that time frame.
I mean, it may not.
These methods won't give us any data on
Oumuamua. It could be 100 years,
which is now too far away for us to capture any new data about it from any of our telescopes. Whatever answers can be found there will be lost to the darkest reaches of interstellar space if we simply wait for another one. Evaluating these alternative options, maybe launching an interstellar probe chase on Oumuamua isn't such a crazy idea after all. It is technically viable, Nothing about it is impossible with our current knowledge and technology. But is it economically viable?
Yeah.
Space missions require many resources. Time, money, materials,
there's James
brains, etc.
Best telescope ever built.
To just let Oumuamua's answers go, trusting that, whether alien or interstellar object, if it happened once, it will happen again, and our solar system will eventually be greeted by its next interstellar visitor. Ultimately, it all comes down to, what is the price we are willing to pay to scratch the itch of our curiosity?
It's going to cost a lot for
Researchers at Project Lyra are certainly considering the investment. Is it worth it?
In
the end,
that's the question.
Multiple theories have been raised to explain Oumuamua and its strange properties. But without more data, we have no idea whether Oumuamua was another dark comet, or proof of alien life, or neither. It may turn out that none of the theories proposed so far are correct.
Yeah, it could be
That's the
something
wonder
different
of
entirely.
science. The more we explore the universe, the more we encounter strange and unexpected phenomena. And as we learn more about them, the better our theories become. Perhaps one day we will encounter more objects like Oumuamua from outside our solar system, which may lend further weight to a particular explanation. The search, even for dark objects that currently act under invisible forces, always fills me with a marvelous curiosity. Only time will tell if these missions to gain more data will be worth it. But that's the terrible, captivating irony of it all. Unless we take the gamble, we'll
just
never
never know. Nope, won't ever know. Ain't that the truth? Yeah,
Thanks
what a
for
great
watching.
video, man.
Making
great
this
video.
required
great video, great channel. Hold on.
long-term
I'll let
planning
this play.
and work, which we were only able to do thanks to the consistency and sustainability of your memberships as astronauts on Patreon. A huge thank you to everyone
if you're so
who
inclined,
signed up. And if you'd like
go
us
over
to
there
make
and
more videos
give
like
them some
this,
support, man.
you can join with the link down below. When you join, you'll be able to watch the whole video ad-free.
Yep, and I'll show it to you.
Credits and submit questions to our team.
There it is.
Meanwhile, click the link to this playlist for more Astrum content.
Yep. They got all kinds of good stuff on the channel. It's a very cool channel. But yeah, I'll leave it in the description, of course, as I always do. Any video that I put on here, I always link it directly, as well as the name of the channel too. But yeah, very, very fascinating. That's a very thought-provoking video, to say the very least. And I mean, I thought that they went over where they thought it came from. So let me just see if I can try. I don't even know if I'll have a chance. My freaking kitty's laying here in front of me. Let's see here. What was I about to look for? All right, hold on. Just give me a second. I'm all kind of frazzled out here. That way I don't have to misspell it or anything. I'll just copy paste. And I might have to do this on Google, because sometimes Brave doesn't give, the greatest search results. But red dwarf star, HIP 3757, which Oumuamua passed near about 1 million years ago. See, I knew they had a decent trajectory, and I don't know if I'd be able to find it in a single image, because it would probably be really hard to put that into an image. Like it's maybe. Let's see. I don't think it's probably going to bring up anything, but I guess it's worth looking for at least. Parent trajectory, Earth sky. No, I'm not interested from the perspective of the Earth. Maybe it's origin, perhaps. Maybe not. Yeah, I mean, I know that's quite a reach to try to see, but it's probably all going to be relative to the solar system only. But anyway, let me just look back here at this red dwarf star that it mentioned. No, hold on, let me go back. Here we go. Believed to have originated from a star system outside our own, of course. Trace this path back to identify potential source stars. One of the leading candidates is the red dwarf star. One of the leading candidates. Other possible stars that could have birthed Oumuamua include the Sun-like star HD 292249 and 2 unnamed stars. All 4 candidate stars currently lack evidence of hosting planets, which raises questions about how Oumuamua could have been ejected from these systems. So, yeah. But let me just see if I can at least find out how far away this star is. Let's take a look. See if it'll be able to tell me. Distance, roughly 77.53 light years away from Earth, based on a parallax measurement of 42.07. Yeah, it might actually show an image. Nah. The Gaia spacecraft, just, I don't know, somehow, maybe it gathers data of red dwarf stars, maybe. But yeah, I mean, okay. That could potentially be where it came from. Now, it'd probably take me a few minutes, but I mean, I don't know. I won't mess with it right now. But if you take, what was the number again? I'll at least give you the number. If I can, oh crap, I fucking deleted it. Well, it was like 194,000 miles an hour. But if you take 194,000 miles an hour, and if, you know, you could do the math. Play it into, or get how many miles that is in light years, and then you just, you know, divide it down. You would be able to get a rough estimate as to how many years that Oumuamua must have traveled if it came from this star. And it's going to be in millions of years. Probably. Well, maybe not millions, maybe a couple of million years. But I think it did say that it may have been traveling for up to 1 million years. Possibly. Yeah, oh yeah, that's what it was. 80. Oh, there it is. 194,613 miles an hour. That's roughly how fast Oumuamua is moving right now. So, you know, 77 light years. You know, taking that and that number of miles per hour. I mean, you might be able to find something out of that, but oh no, yeah, I forgot. Has been. I think it said about 1 million years, didn't it? Nitrogen ice, the size of Oumuamua, could survive 500 million years. Oh, that's if it's made of nitrogen ice. Has been traveling through interstellar space for approximately 500 million years. Assessment based on the survival of nitrogen ice on its surface, which reflects sunlight, could have endured for such a long duration in the interstellar medium. Interstellar medium, if I remember right, it's just the space in between stars, which is a lot of space. Reflects sunlight, could have endured for such a long duration in the interstellar medium. However, the exact origin and age of Oumuamua remains uncertain, as it could have been wandering the galaxy for potentially billions of years. It's absolutely possible. And Oumuamua has its own Wikipedia article. Wow, pretty lengthy one. So yeah, they've got plenty of info if you want to get into the meat and potatoes as far as Oumuamua is concerned. Yeah, I see even hypothetical space missions. They even go over that. I'm sure they go over its composition, its chemistry, what they believe, what it's most likely made out of. Probably even has info on here if it's potentially of alien origin, which I find to be very highly unlikely, but you never know. You really never know. Could be wrong. Oh, that's much more pleasant. I forgot Wikipedia had that option now. So yeah, anyway, that's basically it. Oumuamua. That's a great video, great channel. Astrum it's good. Definitely check them out. And that's all I got. So see ya.